There's a picture of my face. Okay, we're live. Yo, what's up everybody? It's Papa Bale and welcome to the channel. I got a few things that I want to show you today. One of them is this Litz wire coil. And the other is this baby Utron that I have here with a magnetic sphere in the center. So, but this is just a prototype and it is not the right size. So I need to fix that.
And I got this new cube.
And we got the, what's it called?
Cube. Infinite 2x2.
Infinite 2x2 Rubik's Cube.
And you can make two cubes if you want to put them in the right way. So once you have like a star ball.
So there's the sphere, the neodymium sphere in the center. I just need to refit everything. Alright, so you're gonna make your star or did you already make it?
I already put them in the two cubes.
Okay.
So these, and you cannot like physically turn them, you can only it's like a really cool puzzle.
Heck yeah, looks cool.
Yeah, let's put it back into the cube.
Alright, so we'll put the sphere on the pancake coil for now. Gotta change up the size of that Utron just a little bit so we can put the rods in either side and have it enclose around the sphere entirely. So in essence it'll be a rod with a sphere in the center, and that's kind of how we want it. Okay, we're going to put a little bit of juice. And that's 3 volts in. We are using 3 16 gauge coils at 280 turns per coil. At 120 degree positions here. But that's 3 volts in. And we're drawing about 150 milliamps, 200 milliamps. Oh, that looks so cool.
Yeah. Well, you can't break.
You're good.
It's good part. It's just always going to fall back into a cube, even though you don't find the way. So we're back into a regular 2x2.
Alright, so I'm going to go over to the other. Nice.
Do you make motors for bikes?
Motors for bikes? No. I might get into that. Seems like it's up around the same field as what I'm doing here.
Put a motor on my bike.
Yeah, that'd be fun.
Let's get it.
Alright, so
I think how you learn the physics. So.
That looks like a proper electrical engineer's work table.
thank you. You mean well used or well loved?
Yeah.
Alright, we're going to turn this up to 2 volts, 2.5 volts. And this is the pancake coil that I'm turning on right now.
Well done, yes.
Alright, so we're going to start at 10 hertz and we're going to go to 20. Alright, so here's 10. We'll go up by ones from 10. Actually, we'll go to 7. We'll start at 7. Alright, you can see the sphere jumping around. That's 7 hertz. We're getting some motion from the sphere. Bump it up to 8. Alright, we got up to 13 hertz at that point. Now this is 20. And you can see the meter going up steadily now. Like really fast with the DC collection. But it won't spin at 20 hertz. You gotta start it at a lower hertz.
What's the process of what you're trying to do?
Well, right now I'm seeing how much DC voltage will stack up in my cap bank from running the coil here. And then I don't know what I'm going to do with it. Probably anything I can. You got to see what the flow through is. You got to see how much compared to what's being spent out of the cap bank, what's being inputted into the cap bank. So there's a lot more stuff that we can do here with this. It's kind of open-ended because I didn't start with the schematic, okay? I didn't start at the ass end of the project. I started at the beginning, literally. I don't know. It just I feel like I have a lot of freedom right now.
You,
So this is 2.3 volts in. To the coil. We're drawing 700 milliamps and we're still stacking. What happens is you get to the point where what you're stacking and the pushback, they equal out and you stop gaining DC voltage in the cap bank. It's gonna level out at about 11.5, 11.45 volts. At least that's what it did the last time.
great way to learn, finding your own path sometimes better than following one that's been already done.
I agree. It's been a lot of fun messing up along the way as well.
That's from Bass Hatcher.
Thanks, Bass. All right, so we're at 3 volts. Four volts. Let's see what our readings are now. So with the increase in voltage, the resonant frequency changes, and I don't know what the new one is. So we'll have to find that. We're still going down currently. Maybe we turn it back down. 20. Well, you can start to hear it now at 90 hertz.
Yeah, you can hear that.
You okay? Okay. Just checking. So that was up to about 500 hertz. And we're not getting any gain. So I'm going to put it back down to like 2.5. Two 2.3. Let me just see if I'm wrong. Oh, look at that. Look at how much it's bounding up, dude. It is now generating at a rapid pace. At 20 hertz and 2.36 volts in. So 2.5 volts in. I'm gonna have to do some more experimentation before I, turn up the juice. And that wheel in the center, it's only spinning at on 3 volts.
Ben says my work is a tad different. Working more with Fortescue, quarter neon vector operations, asymmetry, etc.
Awesome. Sounds very precise.
Professional.
Really cool, man. That's awesome. So this is, because there's 3 coils, you get a much more calm response. But there's enough torque there for the bearing to skip, and it's a ceramic bearing, so it's pretty awesome, I think, for a pulse motor. Oh, Jesus. Sweet. I'm going to make sure that's all together. So I'm going to cut the power. So at 2.35 volts at 700 milliamps is what this Pancake coil was running at. So we're going to go down to 7. We're going to try and get this thing going. 12 appears to be a little too high. Let's back it down to 8. So I got up to 15. So that's not that great, but I mean, it's better than nothing, I guess. So it went from 7 to 15 hertz. $19 there. I think, you know, if I can get it a steady increase, it'll go up to like 30 or so. Alright, I'm going to try and stack the DC in the cat bank for right now. That's the meter reading. I do want to show you this Litz wire coil that I made. And I'll look that up on the middle wheel. So we take out that. Move this here, put that back on its perch. Add this in here like this. Okay. So trigger 1. Bingo. Trigger 2. I got a mark that's really easy to do, really easy to read. This is drive 2. If I did it right, it should start up pretty instantaneously when I turn the power on. Now the lights on the cat bank are starting to turn on because wow, why is it only going up that much? Let's turn it on. Let's see where we're at. Sweet. Yes. Yeah. Just make sure I got everything here. D2, D1. right, let's turn it on. Now that coil, watch, now I can turn it up. That's 9 volts. It's a smooth ride. It's got a nice, its length is even on the trigger and the drive. It's smooth. And it's connected to the other two 16 gauge coils currently.
Did you make that one?
Yeah. Yeah, I made that Litz coil, yeah. It's a 34 stranded, it's 26 gauge. We're only drawing like 400 milliamps at 12 volts. So this is 12 volts. The other system wouldn't even go to 12 volts before it like broke. So here you go. That's 12 volts in. I'm pretty sure we're getting some kind of wave, but it's not hooked up to the coil right now. So it's still revving up, man. It's still increasing in speed. That's awesome. I'm gonna cut it off though. So I go to 19 hertz, it goes down. I go to 21 hertz, it goes down. So that means 20 is the plane where everything happens. There might be some less than a hertz that I could do.
So 20 hertz?
Yeah. For this particular coil.
Plus or minus 0.5 hertz?
No.
The interaction happens at 20 hertz.
Yeah. I just was checking it. Right, okay, 19.9.
Yeah?
We're getting some, yeah.
So it might be a plus or minus 0.1.
We'll see. Still going up at 0.8.
Okay.
It's going up, I believe, faster at 0.9 though. So
And then check 20.1 also. After you go down. Or it's
okay, no, it's below 20. 20 is the max.
okay, so 20 is the top. Got it. So it could be 19.5.
Let me go all the way down to 5. Nope, 5's going down. So it's in between 19.5 and 20.
Yep.
6, 7. 7's going up,
Okay.
but that's the, okay, it's going up pretty quickly.
So 7, 8, and 9 go up.
7, 8, 9, and 0. So let's go down, and we got one more to go down. So let's go to, start at 7 and go to the next decimal. Okay, 7.1 is going up. 1971 is an increase. 1972 increase. 73 increase. well, we're measuring the DC and whether or not it's going up. So that might be not exactly the way we want to do this. So what I'm going to do is I'm going to clip these to the AC side and see what happens. I think that makes it and now we'll switch it to AC. Oh yeah, this is what we want. Wow, that is crazy. This is coming from the Pancake coil. Wow, does that say 20 or does that say 2000? It's hard to see it. Every now and then we get like a nice wave, but so I'm gonna put these back on the DC side. I mean, that looks interesting and everything, but I don't know how to. I don't have good enough vision to see. Wow, that's awesome. $19.80. I think that's steady. It's a 1046. 1981. 2, 3, 4. Okay, it's going down now. Okay, we're at 20 again. Looks like we've maxed out. We've capped it somehow. Somehow it's not as much as it was before.
What is FNIRSI?
Yeah, I believe it's a brand name of oscilloscope.
Oh, okay. Is that,
Yeah, on the bottom. And this isn't one on the top.
okay,
But this is one down here.
yeah. And that's from Sammy.
Yeah, it's I definitely have one of those, yes. Alright.
Nice. So,
Cool. Yeah, I like that one. I mean, the oscilloscope on that one isn't that great. Um, it's really kind of hard to read. It's kind of hard to set up too. So. But the meter reading is auto. It's great.
Thousand views.
Nice. All right. So yeah, I just turned it up to 3.5, and I can't nail the frequency. But we're gonna go up one at a time until we start getting something. There we go. What's that? 1,000. 1,000 hertz, man. We're getting some nice gen. That's a nice squeak there. That's reduced the milliamp draw to 600.
Do you know where I can get a BLDC encoder? Only the encoder.
No, or maybe Amazon. If maybe. I'm not sure. See, I've made pretty much everything that you see here, except for like the multimeters and the little prepackaged stuff. Wow. I know that's getting loud, isn't it?
Yeah.
So that's very high. That's getting to the high frequency, I would imagine. 1,200 and some odd. We're now generating 13 volts at 3 volts in. Nuts. That's crazy. With this, that's amazing. All right, we're gonna.
Are you making encoders? He says, wow, impressive.
Yeah, I'm not. No, I don't know. I don't know what an encoder is really.
And Darren said, nice.
Look at it go up now. I mean, holy smoke. That's because it's a direct feed. Holy smoke. So you can't just, it won't just stop when you turn it off. You gotta actually turn the power off. And that might be because there's a problem with the transistor, but I could imagine. That's awesome.
Yeah.
So we got some higher frequency jazz going on with this, and I like that because I was stuck down in like the tens of the hertz. Now I'm in the kilohertz, and I like that.
want to see some more Utron content? 84% yes.
Oh, nice. That's awesome.
We just published a video, so you can check it out on the main channel.
Yeah. Sorry, but this is my first Utron rotor creation. So you got your your 4 neodymium cubes. You can make it 2 if you want. And then you close this on the top. You got that hollow center, so if there's any static going on, it'll be going on in the center. You will have a shaft going through there, but I think that kind of works to your benefit, actually. So I'm gonna
What type of magnets do you use?
neodymium. I'm just going to do this very delicately. Wow, it's not wanting to go on, but I'll get it. Got it. Ba-bam. All right, sorry about that. The magnets did not want to go in, but there you go, man, and that's pretty seamless. Utron right there. It will come apart though. But yeah, I'm gonna work on a vertical one that's gonna go with that neosphere in the center. I was thinking about running this with the SSG and then having the output run the coil. So I love the Litz wire coil and its ability to let me get up to generation voltage. Because when you're going this fast at 3 volts, maybe even faster, but you're not getting the generation because you're not putting the energy in. So yeah, it's a give and take. Honestly, you got to find a happy medium, a balance. if you're planning on doing the generation thing, you gotta balance it out. Because you gotta put at least 12 volts in, or 3 volts in, or whatever your output is. And that's so smooth, man. That's running so smooth. So yeah, here's the idea I had for the sphere. You got a little tiny Utron like that. And you got a rod sticking out of each end of it like this. And then you got your vertical, you can spin it. But you see that? And then it's like right in there. But when you put the rods in here, if they're magnetic, your rods, your north-south will be this way. And you want it to be this way. You see what I'm saying? And that's the thing with the spheres. You can't really tell which orientation without holding it properly or having something to have it magnetized to, for you to tell which hemisphere is where. You know, it's more difficult to tell that. But I'm going to have to get non-magnetic poles, and I'm going to have to make sure that that's in there at least diagonally, or it's not going to work the way I want it to. See, that's the other thing that I'm saying. Magnets, what makes a magnet like really special is how they make their hemispheres. The hemisphericals, man.
Hemispherical.
See, it's cut down the middle like this, and here's your north and here's your south, right? But if you cut it down the middle like this, if you cut it like this, and there's your north and there's your south, then you got a super magnet. I'm telling you, man, you gotta get your magnets. You gotta know how to orient it. But I've been dying to get my hands on a donut magnet like that. It's like you cut them, and when you get a big long roll of ferrite like this, and you start cutting them, right? And that orients them the flat way. Oh man, but you know, you want to orient them the other way, so that you can get a spin out of them, a different type of spin. I mean, but it's obviously costs a lot of money to cut them the other way, or they do it a lot more, and it'd be like you know, it'd be more prevalent, be more around. So when I started working with Utrons, I was talking to my buddy about the Otis T Car X1, some like a time machine craft. And I started out with Utrons that were this big, just an inch by an inch by an inch, and I couldn't get them to spin. I was like, damn it, they're not going to spin. So I'm like, how can I get the Utrons to spin? And I'm like, dang, I'm just going to make a rotor out of a neutron, and that will get it to spin. But honestly, in order for this to work, I think it needs to be like solid copper, like real straight up copper. So like when I get $10,000, I'll have somebody mill me one. You know, like cut out all my holes and stuff. Yeah. Like not 3D print. I don't know if the 3D printed copper is good enough for this project.
You need a Smith.
Yeah, and I'm not talking about the the copper infused PLA. I'm talking about copper,
Right.
printed copper. I don't know if it's good enough. I think like a solid, either aluminum, piece of aluminum, or a solid piece of copper that milled out the center. Like for this one, you mill out the center, you put the little ball inside, you close it up, and then this will spin. But you know, if it's aluminum, you then now yoked your magnet, and it's not going to reach as far as it used to. So I think copper would be the best way to do this. Although I do have an aluminum Utron from PCB Way, same size as this one, except it's aluminum with some nubs so it can roll in a bearing. Oh man, so much fun playing with these things. But when I got that reading at like, you know, a kilohertz, I was happy. That was amazing. Matter of fact, we're going to turn this back on. We're going to start it at a kilohertz this time. 4 volts in. Well, we're going to start it at 1290 hertz. Let's turn the meter here back on. I love that Litz wire coil, man. It's so much fun to play with. I want to try 1500. Wow, that is such a nice sound. That's ringing for sure. That's not resonant frequency, but that's pretty good.
10 likes.
Thank you. Thank you for the likes. Subscribe. Come play with us. We like doing all kinds of stuff. None of it's very sophisticated though, I don't think. It's really rudimentary. It's beginner level. But it is playing with all of the you know, newer stuff. I'm going to get into Tesla coils. I have a little Tesla coil over here, but it's a, you know, it's a mini one. It doesn't have a big winding or anything. It has a smaller winding. All right, so we've got about 17 volts in the cat bank currently. $1,600. Woo! See, but the higher it goes, the less energy I spend. So actually, the colder everything gets. This is all DC, so we're not going to get a wave, really. We're going to get, it's going to be a straight line if I change it to the oscilloscope right now. Almost 30 volts in the cat bank, man. That is freaking awesome. And it's still generating, which means it's still on top of what the pushback would be. But you see it's slowing down. $30 volts. (2,000 hertz). 2 kilohertz. That is a humming right along. It's cold as ice. Well, it's not that cold. It's room temperature. I wish I had like one of those heatometers that can show me like if there is a spot that's heating up, where it's at, because I got a lot of stuff connected here. 40 volts. When we get the point, I'm pretty sure that this coil generates a lot of DC on this cap bank. So it generates a lot of AC that the cap bank then turns into DC. Oh, I wonder that if I hook the DC end of this up to the power in, oh man, that might be interesting.
Yeah, Dula says hello.
Hello, hello. So now we got all this DC electricity generation. What are we going to do with it? And I don't want to send backlash to my power supply, so I can't directly connect it to this power grid here without diodes, like a forward and a reverse diode off of the DC dump from the cap bank straight to here. So that means, oh, should we try that? Yes, I think we should try that. Oh, here's one already set up. That's neat.
Running an open loop at the moment.
Yes. Yes, I'm not using batteries currently. This is a pure testing phase. I might swap over to batteries later tonight. But I have to go below 12 volts a lot of the time, so. So there's the plus. I got another Litz wire coil right here. This is a 38. It's 100 strands of 38. But it's just about the same size as the other one is. It's only 2 ounces. Now we can either directly connect this negative terminal to the negative terminal directly, or we can put a reverse diode on this. I think we're just going to connect it directly. So now the DC has a place to go. We're going to let it build up a little bit, and then we're going to trip the motor. We're going to see if we can't get it to start up. All right, let me turn on the 4 volts that we're going to use to do this. Oh, that is so cool, man. We're spinning the motor and we're gaining on the cap bank. So we're not spending as much as we're gaining. Oh, man, that is so cool. But we got that 2000 kilohertz sound going. We'll go to 2500 hertz. Oh my god, man, I'm so excited. But it is like, you can see that it's draining the cap bank, but also we're gaining, or maybe we might be just leveling out, but we're gaining, it looks like, in the cap bank, which means that this coil is producing more electricity at 4 volts, 300 milliamps than this one is spending.
So
Currently.
Is it closed loop now?
No, it's, no. Nothing's hooked up to the batteries currently. And even in a closed loop system, I'm gonna have a battery in it. But this system is running this system at a gain. That's what's happening currently. But you see, it starts sucking it out, like, a lot faster. See, it's hovering right around 6. What happened there? It looks like we're losing now. Oh, there we go. So there is a wave of gain and loss happening right now. All within the 0.59, 5.9, all happening within 5.9.
Just caps running the system?
No, there's a power supply, a DC buck converter over there running at 4.16 volts and 300 milliamps. So with 4 volts and 300 milliamps, I'm getting 6 volts out of the cap bank, which is running fluidly this pulse motor. So now this power supply is hooked up to this pulse motor and it's off. So what's going on is coming from this one, and that power supply is down over there. And I'm not going to move all that. Just going to have to take my word for it. But it looks like we're on a gain, like a gaining streak, and then we'll just lose about a volt. I'm going to continue to increase the hertz.
Add some I can't say it.
Shunts,
Shotsky.
Schottky diodes.
Yeah, so your fill can't make.
Let me think here. I don't need a diode on the cap bank because it starts as an AC cap bank and then is rectified 4 times in the middle by bridge rectifiers, and it comes out the other side DC rectified. So it's already being done by the cap bank itself. And it's full bridge rectifiers, or at least half bridge rectifiers, but I think they're full bridge. And this is all AC coming off of this coil anyway, so. I think it works out pretty good without any extra additions. But you're saying it'll continue to increase if I put a Schottky diode on it.
Yeah, they're super fast, it says.
I got one lying right here.
But he said, oh, okay, cool, for what you were saying.
Yeah, I got this one right here.
Papa Bale is killing it.
Yeah, I'm not quite sure I'm gonna need it though. I'll keep it in mind. And then you want me to put that on the positive note? The Schottky diode?
Gerald's in the house.
What's up, Gerald? How's it going? I found my other Pancake coil. It's a nicer one, I think. So 2640 hertz is where it's at right now. $27.
There it said the negative.
So you want me to negative, huh? So it's like a back EMF type thing? Three kilohertz. We're at 4.16 volts, 300 milliamps.
Cap seemed to charge better when pulsed.
I see what you're saying. Yeah, but do I reverse it or just put it on there regular? So this is a flow that's happening right here. I'm putting the 4 volts, 300 milliamps into this coil, pulsed at 300 kilohertz. And that is going into this cap bank, being rectified into DC, and running this pulse motor at its current speed at 4 volts, 300 milliamps. I think that's pretty cool. And it's kind of stabilized at, 6 volts of usable energy with this as a load. So I think that's phenomenal. If anything, we're getting roughly 2 volts out more than we're putting in after running that. So let's check. We almost got 100 milliamps of current coming out. Let's see about AC. 35 AC. So DC is what we want. DC current. So right around 100 milliamps of DC current. I think that's pretty good, especially for how high the frequency is. Look at how tiny this coil is, though. I mean, it's... So the coil is hooked together in series, and it's a bifilar pancake coil. I'm going to change the wave to a square wave. Look at how much voltage we got off of just changing the wave. We got an additional 2 volts. We are spending 200 more milliamps though. So that's not really a big deal. Let's see what the... Oh, 142, almost 150 milliamps now. That's awesome. But that's still nothing to the 5 we're putting in.
Technically, that's over unity.
What's that?
Technically, that's over unity.
Right here? This right now? Awesome. That's awesome. So it's 4.16 in at 500 milliamps. And we're getting 8 on top of running the pulse motor. In addition to running the pulse motor. So yeah, I would say that is more energy than we're putting in.
Can you reduce the duty cycle?
Yeah. It's a 120, so what do you think I should put it at? Like 26%? We'll try that. $33%.
On the pulse generator.
Yep, we're at 26 right now. So what I do is I find the circumference of my rotor, right? Or that's if it's on the rotor. And then I find the length of my magnets, which is 1 inch. So I subtract 3 from the circumference. Well, what I'm looking for is that 3 inches is supposed to add up to a percentage of duty cycle out of the circumference of the rotor. Because it's how much it's on, right? So we get an even, like 8 volts for 26. $33. So I think it is right around 26%. All right, so let's do this. Let's take it off of the cap bank's DC side and put it on the AC side. All right, so let's flop it to AC. So we're not making much AC. Well, it's flowing, so it's not going to be much AC. We're getting a lot more DC out the other side because this is spending less than this is making. So it's piling up in the caps in the cap bank. And the rotor is only drawing exactly what it needs from the cap bank. All right, so, and it's starting to pick up speed too, man. It is getting going. Alright, so we were up a little high, it looks like. We're getting back into the zone here. Nice. So this is 2000 hertz, 2 kilohertz. And we're back up to 3 AC volts. Let's turn on the oh yeah, we got something going on there. I can see it. It's all kinds of spiking. Huh. Alright, so that's our wave. It looks about 18 volts peak to peak. That's amazing. That is a really weird wave. I haven't seen one like that. Let's check the voltage. Yeah, we'll turn it down a little bit so we can see it. Nice. See now how we get the speed to increase here is we got to get the amount of voltage to increase in the cap bank, which means we got to go down, it looks like. Oh, 2000 looks like our new resonant frequency at 3 volts. Well, it's close. It's close. It's going to be in between 2000 and 1900. Right around there, 20-40 hertz. Wow, man, we're getting great. That's nice. That's AC electricity. Here, let's see what the DC is now. Alright, let's flop this again. 8 volts of DC. So there's I would say there's either we've reached a unity, basically this has stopped going up, and it's above what we're putting in, so that would be over unity, I guess. I mean, you come across the proper combination of stuff and it should work, I guess, right? I mean, I'm trying to think of where the energy is not over unity. I'm trying to debunk this in any way that I possibly can, without just going to the stars and saying, wow, the almighty pulse motor god said it was no good. The physics god.
Awesome for 4 volts in.
Yeah. I don't know. I think this is running on 8 volts though, is what I think. The motor. But yeah, this coil is running on 4 volts, 700 milliamps now. So it did increase in its spending. I don't know why. Because of a reduction in hertz by about a kilohertz. So that's stable. I believe that this coil is pumping out enough AC voltage for this cap bank to convert it to DC, have it be, let's do the math on this. There's 4 volts, 4.1 volts and 700 milliamps going in. So that's going to be about 2.83 watts.
Nice work, Papa Val.
And then this one is going to be 150. We're going to give it 150 just so I can do the math. Times 810. So it's going to be 0.8.
Oh, home.
Yeah.
Plug the phone in.
Oh, thanks. So, unfortunately, 2.8 is going to be more than 0.8. And it's all in the amps. So I'm going to change the wave back to a sine wave. I'll be right back. Maybe I won't. Maybe a square wave is the best way to do this. Sine wave. Let's just try it real quick. Because we're going down, down, down. Yeah, we're going to stay at a square wave. And you could tell the difference in the rotor speed just from me changing the wave. So 2090 hertz. Hold on. Let's turn it down a little bit. Let's turn the voltage down from 4. Whoops. To 2.5. Yeah, you can hear it slowing down. Wow. So I turned it down to 2.5 volts. So that went down to 5 volts, and it's running like it's on 5 volts too. But it's still more than what we're putting in voltage-wise by about 2-fold. But the milliamps being drawn, we're gonna have to change the wave. We have to change the wave to the sine wave. Alright, we're gonna try and bring it back up before it stops. But we gotta redo this, so this is good. 1 kilohertz. Four volts, nice. We're almost to 2 kilohertz. Two kilohertz. So 2 kilohertz is the big number. That's where we're at. 4.114 at 2.5 volts, 200 milliamps. Now we're getting twice as much voltage. Well, almost, and 50 milliamps. So that's 150 milliamp difference.
Small window.
It's a very small window, man. That's 150 milliamps. That's really close. So how would we generate, separately from what we're doing here, 150 milliamps and then add it to the system? And I don't care how we do it. It doesn't matter whether it's through electromagnetism or through chemicals. It doesn't matter. I don't care. Can even be solar or whatever, you know? So now I could revamp the Pancake coil so it makes more energy.
Ferrite core with copper wrapped as a pickup coil.
How much copper? What gauge? Or is it just like a copper plate of some kind? Alright, so now we must...
On the outside of the pulse motor, 120 rats with 20 gauge to do it.
Okay, I have that. Around a ferrite magnet or just a piece of ferrite ferrous iron? But as you can see, like this pulse motor does not require amps to run. It doesn't need amps. This is the number that's running the motor, or what's left above what's running the motor. So, I wonder if we disconnect that, what our readings would be. If we take the load off, what would our readings be?
Ferrite core, like from a old TVA core rated.
I gotcha. So like a 6-inch or an 8-inch Ferrite core. You're talking like a jewel thief, right?
Yeah.
Yeah, it's about time I make myself a jewel thief. So Gerald, I was just wondering how you came across your design for your geometry coil. It's a really unique coil. I'm like when you first built it, I watched a few of your initial experiments. Like right when it first came on, man, I was like, wow, this is cool. Because you can tap into it anywhere, basically, right? And it's equal everywhere you tap in. So I mean, that's above and beyond like over unity. That's be something really cool if I could combine all this stuff with a coil like that. Hmm. Now I got a 36-point rodent coil that I made. Robert Murray. I watched him. He taught me how to make that one.
2,000 views.
Thank you all for checking it out. I really appreciate you guys. You can hear that humming though from the. Here, let me turn it off. And then we'll watch that DC go flying. Watch. Oh no, it went off. Turned off this time. Last time it would remained open like an oscillation, and the cap bank charged phenomenally fast, like it was an open circuit. Or a closed circuit, I should say. But you know what I mean by open, the energy was flowing. Alright, let me see if I remove the magnet, all that noise stops. But the generation continues, so.
Started with Ronan, went to a guy named Mike Powers. Then I created my own, inspired by a series of dreams.
Series of what?
Series of dreams.
Oh, nice. That's awesome. So you used your regenerative time to enhance your coil, man. That's brilliant. Not a lot of people can, do what they do that passionately. And I've watched your videos, man. You're really passionate about, and I've seen your notebook, dude. That is, I wish I got a little notebook, but it's not like that, man. It should be like that, though. I'm depending way too much on my videos to stay the way they are. I need to write more of this stuff down.
I love this work, he said.
Yeah, yeah. So I feel like I may have a bit of a fever. Like I'm sweating, it's hot.
11 binders of notes. Please take notes.
Yeah, you gotta write stuff down. It's just whenever I do it, it's very disorganized. So it's not like the stuff that I write down is worth much. But I mean, the pictures that I draw, I think are pretty good. Like the quasi schematics, man, they're all right. They're not.
I got an idea for that.
Okay.
You just gotta verbalize everything out.
Yeah.
Like get an AI to record what you're saying. I take notes on it.
That's so cool, man. That was so cool. Now, how do I get it back up to 8? Oh yeah, we gotta turn it up to 4 volts to get 8. I'm gonna try and get the milliamps draw. There it is, 100 milliamps. At 2.4 volts. Let's see if we can get it even lower.
Yeah, he said I'm a horrible mess of notes, but I go back, reorganize, which helps me move forward.
That's nice to have a strategy. Oh, we are below 100 milliamps in. Okay, I've turned it up to 7,400 hertz. And we are down to below 100 milliamps. And it looks like 3.4 in. So we're really, 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 really close right now. But as you can see, we're going pretty slow. I wish I had more of a better reading on how many milliamps were actually being drawn.
Yeah, go Papa Bell.
Woo. Hell yeah. Guys, I think we're really onto something here. But of course, then that's what I've always thought about the over unity pulse motor. Pace is not going to be fast. It's not going. I mean, it'll have a frequency that you can't count with your mouth, but it's not going to be going super duper fast because of the voltage that's going into it, unless there's a scalable over unity plateau kind of thing going on at different hertz scales, because I've seen stuff like that happen too. But this is 750 kilohertz, or no, this is 7 kilohertz, 700, 7.5 kilohertz. And we've got 3.5 volts in the cap bank. So this is 3.5 volts worth of spin damage here. 2.5 going in, 0 milliamps on the draw, which means it's in between 0 and 100. And this is at 35. So as long as that is not above 70 milliamps, we are at over unity right now. Woo! But you'd think it'd be like going faster or something like that. I hope it still goes, still keeps going. Hope that's Litz wire coil in there. Keeps it going. You can barely hear it chirping now. So I'm thinking of a different way to structure my experiments, like actually have an experiment before I start. Because usually I only have, the motor, the physical motor in mind, and I don't even have to draw it out, because usually it works. I mean, like 65% of the time it works right off the bat, and the other 35% of the time I might have a problem. But most of the time it just works right off the bat with a circuit like this. I'm not using SSG right now, which may or may not be, work, because it has resistance in it. There's no resistance in this except for the coils. It's the only resistance in the whole thing. Oh, and the halogen light bulb between the collector and the emitter.
Alright, Gerald said slow and sure wins the race. I gotta take off. Thank you for the compliments. Keep kicking its ass.
Thanks, Gerald. No problem, man. You rock. I'll catch you on builds later on or something. Oh, that is so cool. But I think if I had my other coil plugged in right now, we'd be going a lot faster than we are, but we'd be drawing a lot more amps. And we would not be close to over unity.
No clumps.
So we've like nestled into a slow pace. We're currently generating 3.5 DC volts off of this Pancake coil. Which you're going to check the amps. 32 milliamps, 33 milliamps. Okay, but here's the cool part. We're at 7,500 hertz. So we're at 7.5 kilohertz on this coil, which means that we're putting 2.5 volts in and we are drawing less than 100 milliamps right now. I don't know exactly how much less than 100, which is not good, but you know, if that math is correct, we are 1 volt up and possibly matching amps in and amps out. So that would be over unity mathematically. But you know, I'm just looking at what I have here. I'm gonna write it down. Real quick, I'm gonna say we're gonna go Pancake, Coil, I can't see what kind of transistor it is, but I want that, so we're gonna do transistor equals I don't know how many turns that is. I mean, I can count them pretty much. I want to say 15 turns, but let's just move on. Voltage in. .45 volts. All right, we'll do milliamps equals question mark. Voltage out. .5 milliamps. Say 30. Load. Pulse motor. So there's definitely a load on this. That is, this motor is loading it down. It's not a great load, but it is a load. And I have to turn this off and charge it because it's running out of juice.
Running out of juice.
So, in order to make this math work, we got to find out exactly how many milliamps we're putting in.
Yanni
It's
is
below.
in the house.
Nice. Who?
Yanni.
Yanni, what's up, my man? So if we are putting in less than 30, we are winning. If we're putting in 33, we're winning. If we're putting in a little bit more milliamps than we're generating, we're still winning. All right, Yanni, we're at 7 kilohertz, 500 hertz, 7.5 kilohertz. We're generating 3.5 volts off the Pancake coil and 300 milliamps. We are putting in 2.45 volts, and I'm not sure how many milliamps we're drawing right now, but it's below 100. I think what I'm going to do actually is swap the power, use the other power supply. It has reading up to 1,000. All right, let's do that. Turn this off. So like 2.5 will be right there. So that's 2.78. Let's see if I transferred that power correctly. So we got to turn it up. Eight. Okay, so now we got 100 and so there's more milliamps being drawn than what I thought. Let's see if we got any juice in this meter still. Okay, so we're generating 4.3 now, which is awesome. And 50. So, I don't know, I guess what I could do yeah, that's about to die. I'm going to turn down the current manually. Right now its floodgates are all the way open. Let's turn it down. Alright, so it looks like that's a minimum draw of 200 milliamps or so. So we're going to turn it all the way up again. let's do the math on that. All right, so there's 2.8 volts and 0.2 amps, so 200 milliamps. Huh. I think it's gonna be like 0.4 watts, right? Like 0.4 watts. And I don't know what we're making, so I don't know. Maybe it's over. The experiment is going to be over. So we are not at over unity because we're at like 4.3 volts and 300 or 30 milliamps or 33 milliamps. And I think this 1000th reading is a lot better than the one I have on here, so we're gonna go with this one. So that's 1.5 watts. It's 1.5 watts. Going into this coil, and then the output of this coil is going into this cap bank, and then this cap bank is feeding this Eve distribution model, which is now running the motor, which is awesome. There's no direct power input from any supply that's running this right now. I love hooking things together, and I love having this make this work. That's awesome. It almost runs it like it would be hooked into it directly, but it's not. It's great. I love the speed we're getting off of 5 volts though. Secondary speed, that's great. That's great. Now, in order for me to charge the multimeter, I have to take the plug out of the phone. But yeah, man, that's great. I think it's really, really close. We're gonna try and make that amp draw go down a little bit. $250 at 10 kilohertz, 10.9 kilohertz. So we're at like, wow, 150 mega amps or milliamps, my bad. Mega amps. $14.5. It's gonna get us down to about where we want to be, I think. But I still think we're only generating about 40 to 50 milliamps, so we're still 100
And he says, good luck.
1500 hertz. And now it's going above 200, so it's below that. 14.5. $1,400. No. 14.4. 5. Hell, you know what? Start moving it up by 1,000. Okay, that's going up high. So 1,500 hertz, 15.4 kilohertz. And we're right around 200 milliamps, 5 volts in. Wow, okay, so that isn't exactly where we want to be. Close, we're really close. We're within 100 milliamps of being where we want to be. But I don't see it getting any lower than it is without changing the coils. And you got to remember that this is a 26 gauge Litz wire coil, and these two coils that are connected to it are 16 gauge coils. So they draw a lot of power. But they have a magnificent magnetic field. It is phenomenal. Yeah, that's all right. Whew. I got this to spin up to 30 hertz, starting at 7 hertz. But I'm going to just take it off of there for now so we don't get the mad hiss. Alright, so we'll pick up where we left off. I think we need to get that number to be a little bit lower, and we may do it by switching up the coils. We'll take the two 16 gauges out, we'll put a little bit longer, a little bit thinner gauge in there to bring the initial draw down. Don't want to make them too long though, because there's really not a lot of energy flowing through this thing, and we don't want the energy to get lost in the coil.
And Gowley says hello.
Hello, hello. So this is a pretty awesome coil. It's 830 turns of 20 gauge times 2, and 830 turns of 32 gauge times 2. So it has 2 full drives and 2 full triggers in the same coil. So yeah, and it's nicely sized to fit a soft iron core in there. I don't see a ferrite being that size though. Two things for the soft iron working in its favor right now. One, I have soft iron. And two, I don't have to buy soft iron, which is, really awesome, because the thing the ferrite core that you're talking about costs about $200. Unless you find it, like you said, or salvage it. So that is definitely not going to happen. Unless, you know, things change. Things do change, though, so maybe it will happen. Hell yeah. Alright, so I'm going to shut this down. And that is eventually going to stop. It's a very smooth riding rotor. It's got 2 ceramic bearings. Very smooth. So yeah, man, we were really, 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 really close to getting, you know, more, putting in less than we're getting out. And I'm gonna put it that way, because you're always putting something in. It's not an issue of the closed loop not having a power source. There's definitely a power source in a closed loop. Because none of this stuff will power itself, ever, without a power supply. Never. It will never happen. So I'm not even going to try and do that. I've hooked it up that way and spin the wheel, and trust me, man, nothing really happens. You get a reading, but that reading dissipates, and as you can see right now, the rotor is slowing down. That happens every time. That's like a given if you don't have a power source. So, and I've always been like really fantasized about it. Like if somebody has something like that, show me. And I don't want to hear the FBI is going to take me to jail if I show you. Because, you know, as soon as I figure this out, I'm going to show everybody. I'm going to write it down. I'm going to show everybody. I don't know what's going to happen. See, that's the thing, man. I haven't figured it all out on paper before I started doing it. So and there's a possibility that I might think of connections that weren't thought of starting the other way from the schematic. Because, and especially if you're not replicating, and I hate replicating. I don't like replicating. Everything that I've made is of my own design. There's been a few designs that I did, a few relays that were collaborative. But I like, see, like this cap bank right here, I don't see anybody else using this cap bank. So anything done with this cap bank is unique. And you can go and buy one. And if you're using it, and I'm saying it incorrectly, good for you. I mean, yes, I encourage people to use things like this because it makes AC to DC conversion simple. It makes it easy, and it's powerful. You saw this cap bank running this pulse motor continuously. So there's an inflow and an outflow, and it's all directional, and it won't blow up in your face. So yeah. And I have a lot of them. You know, I have more than one. These cap banks are awesome. They're literally freaking awesome. They allow you to run a closed loop system without any sparks. Without any extra diodes. Without anything like that. It's just connect the cap bank, connect your output to the cap bank, connect your cap bank to the battery, connect your battery to the input, and you're set. And that thing will run itself till the battery dies. But, I mean, honestly, right now, if there was any danger for people, like, discovering stuff, it might be right now. I mean, I don't know. With all the clean coal stuff going on, I don't know. But I think it's all gravy, and hell yeah, man. If I figure it out and I'm right, and I show people and I go to jail for it, I'm ready to do that. It's not like it's something I want to do, but you know, seriously, I'm not doing this for my health, really. Especially when I'm cleaning off the ends of my wire, I'm not doing it for my health. I'm sure that I'm going to figure something out that somebody doesn't already know. And I hate people reverting back to physics. Yeah, I've heard about all the laws of physics, and this abides the laws of physics. However, I don't think even the physics teachers know the extent of physics. Right now, we don't know anything about it. And we think we do, and that just gets in our way. It gets in our way, and that's why I feel like the way that I've decided to learn how to do this is the better way. I've been referred to as a drunk Helen Keller. I've been referred to as Jimi Hendrix with the way that I decided to learn how to do this. I'm not starting from a schematic and trying to replicate something. I'm starting from asking questions. How do I connect a transistor? That was my first question. You gotta learn your pins, your pin out. And then you gotta know where to connect what and everything. And I learned all that, and that helped me out more than any schematic ever will. And that's just the way it is, man. That knowledge is gonna help me out more than anything I could ever read. And I heard it. You know, maybe that's how I learn, from hearing and analyzing what people tell me when I ask questions. I think it's great. But, you know, within a realm of respect, you don't just go up to somebody and say, hey, even if you've been doing it for 35 years, you don't say, hey, stop, this is the way you do it. Right there, man, you're turning me off. I'm turned off 100%, not listening to you at this point. And if you had something you needed to tell me, you needed to tell me a different way, you know? And I'm working on that myself, you know? I'm not the greatest communicator in the world, but, you know, I try not to step on people's toes like that. And if I do, I apologize, man. I'm truly sorry, because that is not my intent, to step on people's toes. And, you know, for those people that toes got stepped on just for me building this stuff to begin with, I don't care about you. Your opinion does not matter to me. When it comes down to me wasting stuff in your point of view doesn't matter to me anymore. You could scream it till you're blue in the face, man, and I won't even ban you from the channel. I'll let you do it. Anyway, I love this Litz wire coil. This is what was driving all that from the Pancake coil over there. Really, really awesome. It's not the most powerful thing in the world, but it's smooth and it's cheap. And it's 26 gauge trigger. The 26 gauge drive is a little weak, but it's a 26 gauge trigger. And connected with these two coils, it has a significantly lowered amp draw. But yeah, man, I mean, really hard on trying to, the communication thing is like paramount for me because I've noticed that a lot of the people that communicate about this stuff, especially on my channel, might, just be in a hurry or something, and they just, you need this, and then, they just kind of drop a bomb on the channel. I tell you right now, I don't need any of that. I mean, I almost nailed it with what I have right here. And suggestions, like I said, I take them all and I look at all of them, the suggestions. And super chats will definitely be looked at first. If somebody's willing to super chat, they obviously have something they want me to do, or they have something they have to say to me. And, whether it be good or bad, after a super chat, the floor is yours. All right, so we got, I think that the Litz wire coil will allow me to run this pulse motor at 12 volts, which is awesome, because then I can run them in the batteries. I can use the batteries, I can run relays. Yeah, so, but there's lots of stuff I want to think about. I love how much energy this bifilar pancake coil generates at 15 kilohertz. It's a lot compared to what we're putting in. It's almost equal. So I mean, it's not a tremendous amount really, but compared to what's going in, it's almost equal. So that's a lot, And literally, it's within 100 milliamps, and if you convert the 4 volts, it's 2.5 volts going in, or 2.7 volts going in. And it's like 4 volts, 5 volts coming out with 33 milliamps. And if there's we convert the voltage to ampage, or just convert them both to watts to get the equivalent. I'm telling you, man, it is close. We're within frequency range of literally getting that to spin and having more left over than we're putting in. It doesn't matter whether you believe it or not. Because I got it documented, man. There's no way I'm jerry-rigging or fixing up any of this stuff to lie to you. And that's cool, man. If you don't believe, you don't have to believe, really. It's not about believing. I don't believe it. I don't believe in over unity. I don't believe in anything that denies the laws of physics, but if I see it, then I'm conflicted. I always try to debunk it. I always try to figure out where that extra energy is coming from. And usually I find it. So usually I'm like, yeah, that's really what it was. But this is different. This is like 15 kilohertz. I've never played with kilohertz before. It's always been hertz. So that gets the amp draw to run the coil down to, I don't know, within 150 milliamps. Awesome. That's all I gotta say. Truly spectacular. And it's bifilar coil. That pancake coil is basically what's making that happen. There's no resistance in either circuit. I'm not using the SSG currently. I might set that up later though, just to see the difference. And to see if you can get this running with resistance at all. Oh. Oh. Check that out. So there's 4 neodymium cubes in this beast. And it fits right on the pole. There's a hollow spherical center. And I think because it's plastic, you might get some kind of static generation going on this thing. You know, what I could do is ball up like a, well, I don't know, that might reduce the static. But like something that generates static and put it in the hollow center. But I think like a small microfiber cloth or something like that, just to create a little bit of friction in there and create some static electricity. All right, but I think we're going to call it for now. We might be back at you later on this evening. Thanks for hanging out. We really appreciate everybody coming by. Oh, I got to just show you one more thing before everybody goes away. We got a spherical magnet, and it would be encased in this Utron like this, and it'd be on a vertical setup with poles sticking out at each end and have a sphere in the middle. And see, this is copper infused PLA. Just see what spinning that would accomplish, if anything. That's another Utron that'll spin, sure. And they're just like square, so like, you know. But I'm looking for like a conductive paste, like or maybe I'll make my own glue with some iron filings in it or something like that. Just something that is conductive enough. I forgot. Oh yeah, to glue the Utron together. So like the final product is either got to be copper or aluminum solid. So and then when I get my next 10 grand, I'm gonna call up a milling company and get a copper one made, solid copper, and just put the magnets in there and spin it up, see what happens. But I need to find that paste, the conductive material that glues the two halves together and allows the conductivity to flow seamlessly. It's something that we need. So thank you very much. Peace out. Have a wonderful day. Please subscribe, like, hit the notification bell, join up. Think about Super Chat. Peace out.